Hi, good morning, everyone. My name is Zhou. I'm a postdoc in iCamp, Baylor College of Medicine. It is my great honor to present our researches in this event. So today, firstly, I will talk about our group, what we are doing, and I will give a new application of wearable technology on game-based exercise program. Later on, I hope that I can convince all of you that wearable technology can evolutionalize the way to providing balance training. So we recently joined Baylor College of Medicine in surgery department. Leading by Dr. Bisham Najafi, iCamp collaborates engineers and doctors and translates the innovations from engineering to different clinic applications. We also closely collaborate with industries to make sure what we are developing can be commercialized and make an impact. Please visit our website at www.bcm.edu/iCamp. You can find various collaborations we are doing and ongoing projects. So our vision is based on the fact that we cannot manage what we cannot measure. This is true for politics, economics, and also in medicine. In iCamp, we are using wearable technology for assessment of health standards. We improve prevention strategies and provide patient-centric cares. It is proud to indicate that many of our researches in iCamp have already been successfully commercialized. We have a wearable technology for gait balance and physical activity assessment, as well as telehealth systems. Due to the time limitation, I cannot go through all of the details of all of our projects. Later on, a couple of my colleagues will introduce their ongoing project. Today, I will focus on a new application of wearable technology on balance training for patients, especially cancer patients who are suffering from chemotherapy-induced neuropathy. So let's first talk about how wearable technology can change the conventional balance training. What's the current gap? So physiotherapy and strength training are most commonly used balance training. However, both of them are lack of cognitive exercise, which is very important for balance performance. There are some advanced balance training such as Tai Chi, which incorporate with cognitive exercise. However, it is still failed to provide visual feedback to the patient. Without feedback, patient may feel boring of the exercise, and more importantly, they do not know what they are doing is correct or not. They do not know what kind of progress they have. So this is the area that technology can help. So there are some current commercialized technology for balance training on the market. However, they are still unsuitable for those who has very poor balance. For example, Microsoft Kinect has recently become popular for designing fun and personalized exercise. However, from this picture, we can see that there are still many serious limitations. Probably you have already noticed that in this picture, the chair is placed behind the patient, and the trainer is far away from the patient. This is because Kinect uses a camera to capture patient's motion. It requires absolute no block between the camera and the patient, and it requires the trainer to stay outside of the camera site. However, placing a chair in front of the patient is key important to provide confidence for those who has high fear of falling, and the trainer must stay close to the patient to provide help and safety when necessary. Wii Fit is another game-based exercise alternative. In this picture, we can see that now the chair is placed in front of the patient. However, the patient is forced to stand on a narrow platform with limited support, which is very dangerous for the old patient or for those who has very poor balance. In addition, this method doesn't provide any feedback of the joint motion. So wearable technology, especially wearable sensor, can address these shortcomings. It can provide feedback of the joint motion, so why not combine it with virtual reality to design new balance training? Actually, in iCamp, we designed a new game-based balance exercise program based on tasks such as weight shifting and balancing on single leg. So our exercise is very simple. We attach the wearable sensor on patients and measure to capture their joint motion. The joint motion can be translated into our self-divide interface, so the patient can navigate a virtual cursor on the computer screen. So the patient navigate their ankles they rotate their ankles to navigate the cursor into each target circle in good time to pop the circle. And so they need to coordinate the movement of their hip and their ankle to learn how to keep in balance. We also have another exercise game called the virtual obstacle coursing. The lower limbs of the patient are represented as 2 sticks on the computer screen. There is an obstacle come approach to the patient, and the patient needs to lift the leg in good time and height to let the obstacle passing through. So our environment can provide visual feedback to the patient for their progress. It is simply designed so the patient can perceive their motor arrows without being distracted. So we applied this new technology in randomized control trial on cancer patients suffering from chemotherapy-induced neuropathy. The intervention group participated twice a week balance training for 4 weeks, and the control group just received the Eurocare at home. So this is our setup. Simply, a patient is stand in front of the computer screen, and everything is computerized. Of course, we have someone next to the patient to provide help and safety when necessary. We measured the posture balance data in double stance, eyes open, eyes closed, and semi-tandem, eyes open. The balance data includes center of mass sway, hip sway, and ankle sway. We also measured the gait parameter during a 20-minute walk, include gait speed and stride variables. Look at the result. So the intervention group has significant improvement of the center of mass sway compared to the control group. We also have significant enhancement of ankle and hip sway. So we mentioned our balance training is patient-centric. So let's hear what the patient feel about our program.
Since I've been in this study, I'm not as afraid of doing things, which has given me some of my life back, some of the enjoyment in my life back. I can walk in crowds now. I used to be so afraid of getting bumped and knocked over in a crowd. Now I feel a little more stable on my feet.
Yeah, so balance and the confidence of walking in crowd. So we also realized that there are many patients who cannot stand and do the exercise, but during sitting posture, they can still move their foot and do some foot exercise to get benefit. So the next level we are working is developing balance training during for bed-bound patients during sitting and lying on bed posture. Thank you so much.